We continue to have a closer look at classes and objects. What we covered so far is how to overload methods and how to overload constructors. We said overloading methods is to have multiple methods that share the same name, but they have different parameters list. And we said that's useful if you have multiple methods doing the same functionality and you don't want to come up with new name. It doesn't make sense. But at the same time, Java will not accept the same exact signature of a method, which is basically the name of the method along with the list and the order of the parameters input. So overloading a method is to use the same name but try to change the parameters list. We said that can be changed by flipping parameters types, like int float is different from float int, using int float float. All of these are valid changes or different signatures for the same method. The same goes with constructors. For the single class, you can have multiple constructors, and that can be useful, and we will cover this today. In this lecture, we are going to cover how to pass objects as parameters or arguments for a method and how to return objects from methods as a return data type. We have done this using primitive data types and maybe a string so far in our lectures and labs. But today we want to look at more complex objects that we define and how to use them and to interact with methods. Now the lecture is going to be divided into two parts. The first part is going to be building one of the classes as a practice together. And if you're familiar with how to write a class by this point, you can fast forward this part. And I will indicate at which minute you should continue to see the new topic. If you would like to review how to write a class from a UML, then you can continue at the regular pace and try to see how we're going to do this. The class that we're going to rely on for this, and we are going to build that, and then we come and talk about passing objects. It's called an inventory item, and this one is defined in the book. Let's have a look at this. So if you go to page 368, you will find, let's zoom in here, the inventory item class. And this is the UML that defines the inventory item class. So let's keep this one here and build this class using our BlueJ here. We are going to create a new project for meeting 11.3, and here let's define a new class and call it inventory item. All right, so here is inventory item, and we are going to I'm just going to clear this for now. So we have class inventory item. We have a constructor pre-populated here, and I'm going to delete this one. All right, so let's start with the fields from, if you have a look here, from the UML of the inventory item class, you can see that we have two fields, both are private, right? So if I try to change this color, red pen, all right, there we go, here. So here, both are private, right? So that's why we have that negative here. One is called description, the other is units. One of them is string, the other is an int. So in this case, I can say private string description, private int units. All right, then we will notice that we have three constructors. All right, three of them are public. The first constructor is the no-arg constructor, so we could use this one here, no parameter constructor, and that is something that is going to set our description. If you remember from the previous lecture, strings or objects are set to be So if you have a string, you could put it as empty, all right? Or you could actually, since string is an object, then you could make it null. And units, because it's a numerical field, then it should be set to 0. So that's the first constructor. It takes no inputs, no arg, and this is what we do with it. The second one is going to be a constructor that takes one input, right, which is here. So the following constructor accepts a string. So in this case, I can say public, again, inventory item, that's the name of the class. It takes a single input, which is a string. Let's say it's called D here, according to the UML again. So this D, and then here becomes a description is set to D, while units is set to 0. All right. Now we have a third constructor. So this process here, we are overloading constructors, as we explained before. All right. So I have a couple of items that are pre-written here just to save some time. So the following constructor accepts the string argument and set to the description field, or the description field is set to that input, and we have an argument that is called U for units. So here, public inventory item string D and U, and set description to be D, set units to be U. So that takes care of the 3 constructors. So we are done with this. All right, then we have 2 setters and 2 getters. It's very straightforward, right? So in this case, we will start with the set description. So that would be public, goes positive. Since it sets, it doesn't return anything, so the return data type is void. And remember, all constructors, they never have return data type. So return data type is void for the setter, and it's called set description. And to set the description, we have to take an input argument, which is string D, and here set description to D. All right, then we have set units. That would be a public set, no return data type, void, set units, and it takes a single input int U, and it sets units to U, and that's it. Then we will have our getters. So the first one is going to be get description, method that returns the value of the description field. So in this case, we have public. It returns something. It returns the description, which is a string. So the string is the return data type. All right, and it's called get description. It takes no inputs because it just goes and gets that description from upstairs, right? So in this case here, if you remember our analogy that we used in the lecture, so return description, and then the last one would be to get units, and that would be public int get units, and it would return units. So that's it. So that's I think we covered everything defined in that UML. And that's a very simple class that defines inventory items. So it's an inventory item that could be like a hammer, and I have of these. So hammer is the description, units would be 5. So that's a very simple class to be used to describe or to create an inventory item. So that's it. So the next thing we will do now is to go back to the main topic of this lecture and learn how to pass objects as arguments to methods. Now, one thing that we need to understand here is that in Java, whenever you pass an argument to a method, all right, what happens is that Java passes this by value, all right. So what happens is that it sends to that to that method a copy of the value that you have, all right. Now, to understand what does that mean here and what that means in our case, we will go back to our old sketch of the memory. All right, so let's assume here that we have our stack memory. All right, so we have our stack memory, and then we have a reference variable. Let's call it R for rectangle, right? So we have R here, and this is pointing to an object that has a length and width, the 5 and 10 again. All right, and that's in the heap memory as we imagine here. All right, so what is in there in that reference variable? So R is pointing to what? R is actually the name of a place here in the stack memory that has an address, or the hash that points to that object in the memory. So in this case here, all right, when you pass this to another method, what you are really passing is that value here, not the actual object. All right, so this is something that you need to understand. This is the core of this topic and lecture, the concept. So the value of the reference variable, which is basically the address or the reference to the object, is the one that gets passed, all right, not a copy of the object. And that's important, all right? So when a method receives a reference variable as an argument, it's possible for the method to modify the contents. So to understand what that means, let's assume that I go and write something in the code that says like this. Let's actually write it in the code. All right, so I'm going to create a new class. I'm going to call it pass object. All right, which is going to be a demo that is using inventory item. So I go to pass object here, and what we do, let's clear that out. All right, so here I'm going to build the main method, write the main method, static void main string ars, and here what I'm going to do is to create an inventory item object. I will call it item is equal to new inventory item, and I'm going to give that item the name wrench, the description, and I have 20 units of this. All right, and then what I want to do is to create a method here. All right, so another method, public void display item, which is a method that is specialized in printing items. So whenever I pass an item to this method, it's going to take it and print the data or the information about this item. So in this case, this method is expecting items, an inventory item, as an input. So in this way, I can define the parameter here as an inventory item called I, for example. All right. And then what I'm going to do is that given this inventory item I, I would like to print the information, so I'm going to print system.out.println. All right, and I'm going to say description I.get description, and then do something very similar with the units. So get units, and that would be in the units. All right, very straightforward. And then what I want to do here, and there is a mistake that is coming, and I hope at this point you know what is that error that we are going to get. All right, so here I created an object. Here I would like to pass the object to the display item method. All right, so I hope you know what's coming here. Display item and display the information of item. Do you think this is going to compile? BlueJ told us no, it's not going to compile. Why do you think? So from previous lecture, if you remember, we have main method is a static method, and now we are trying to call a non-static method in the static context. It's not going to work. All right, so non-static method cannot be called here. So what that means is that I need to set this also to be static. All right, so that's it. So I created an inventory item using that class that we defined here, and then all I'm trying to do is to just factor my code in a way that there is a method specialized in printing information of inventory items. So this way I can break the complexity of the code and distribute these tasks, delegate the tasks to separate methods. So if I try to run this here, it's going to run and it's going to print description range units from. All right, now this seems very intuitive. It makes sense. Item is passed as an argument. Item is mapped to I. I got I.get description, I.get units. All right, so that makes perfect sense. Now, to understand what we were talking about here and how we are saying it passed by value, not by reference, let's now imagine that this display item is not as just simple as printing these two statements. Instead, it's going to say I.set description or set units to become 0. So what do we expect? We expect that I.set units is going to be 0. All right. Now, if I go back here after I return from display item and try to print the units of item. So what I'm going to do is to say system.out.println, and I'm going to just say item.get units. All right, so that's it. Compile here. Now what do you think the units will be now? It became 0. All right, so this is the core of this whole lecture. If you need to focus on any part of this lecture, is this part. This 0 that you got here tells you a lot of things. It tells you that even though we try to map item to I, so I does its function to print, get description, get units, and work. If I wanted to change any of the parameters or fields of my item, it's going to change it. So that is what we mean by passing by value. Now let's visualize what happened here. All right, we said here display item, and let's say we passed R. Here I want you to map to, I don't want to talk about the inventory item here. It's a lot of writing, so we go back to the to the rectangle class, but try to fuse both examples together. So I'm going to display item very similar to display item inventory item, and I'm displaying R. All right. Now, if we assume that display item was defined as public void display item rectangle I, something like this. So what is really happening is that, as we know, is that R should be mapped to I. I don't know why this is not clear here. I should be mapped to I, right? Now, what is really happening is that for this method, temporarily, the I is going to be created here as a reference variable of type rectangle, pointing with an address to something. Now, which address is this? It's exactly that one here. So when I said R is mapped to I, what I mean is that this address is copied to I. So what does that tell you is that I, whenever it wants to use this address, it's going to be pointing to the same exact object in the memory. So this means saying that I is equal to R does not create a completely new object similar to this one in the memory. Instead, it copies the address and make both of them point to the same object in the memory. And that's why when I said I dot set, let's say length, it would change that length. All right, does that make sense? All right, so that would be the same example of having the inventory item. You have item here, it has certain address, it's pointing to a memory here, an object that has a description of range, and it has a units field which has 20 in it. Then you say display item, which here it's called public void display item inventory item I, something like this. All right, so now we are saying item is mapped to I. Now item mapped to I means in the memory I is created here, it has the same address exactly like this one, which makes it point to the same object in the memory. And that's why I dot set units to 0 in the method would go and set that one to 0. So that's the core of this concept here. This is what happened when you do something like this. All right, that is going to change the contents of item here. All right, so that is one thing to think about as you pass inputs to methods, like objects to methods. All right, so so that's this. Now the other part that we need to cover is what happens if you go back from a method. All right, so return an inventory item from a method. That's basically what we're saying here. Now to do this, I'm going to create a new example. So here I'm going to create a new class called return objects. All right, so that's the second example that we will have here. Now in return object class, what I'm going to do is to assume that I'm building some kind of an application for a user who wants to have this inventory item software, and here we will have our main method. So public static void main string args. And then what we will do here is that we will say, okay, first of all, I'm going to declare a reference variable. So inventory item, it's called item. Now, instead of prompting the user for the data here, what I'm going to do is to try to create a method that prompts the user for the data, create the item, and then return to me that ready-made item. So I'm going to import java.util.scanner. And then here, what I'm going to do is just go and say, all right, so that item that I just declared, I would like to get the information about it using a method specialized in doing this called get data, something like this. All right, so this means I would like to go and declare or define a method called get data. All right, so here I'll go and say, all right, so here private, because it's not going to be used outside. It has to be static, so I can call it from the main method. It's going to return to me an inventory item, right? And it's called get data, and that's it. All right, so in this get data, what I'm going to do is to prompt the user and get the information from the user. So I have a string description here. I have an int units, and I'm going to declare a scanner. KB is equal to new scanner, link it to system.n. And then I'm going to prompt the user system.out.println. And I'm going to say, for example, here, enter the item description. All right, let's do it print. So this way it stays on the same line. And then what I'm going to do is to assign this to description. So kb dot next line. And here I'm going to do the same thing, but this time with units. And units is an int, so I'm going to say next int and store that in units. All right, so now I have units, I have description, and what I want to do, notice here the objective here. In the main method, you declared inventory item. That should be a complete inventory item. But then you said get data, I would like you to populate this item here. Now, for me, item is an object of inventory item type. Now, here you got the pieces that forms an inventory item object, description and units. And what you want to do is to return that as an object of inventory item type to be stored in item here. Now, to do this, you need to return it as an inventory item, so you need to create an inventory item here. All right, so what I could do is that I said inventory item temp item is equal to new inventory item of with the data description and units. Then what I will do next is that I'm going to return that temp item to my method. So you see here the link, inventory item declared, get data gets the pieces, form an inventory item object, return that as an inventory item object, which gets assigned to an inventory item object item here. All right, then I could go and do something like this. Here I could take that, put it here, make it private, for example, remove that part here, and use this other method to print the item for me. All right, very simple. Here. So here I could go and say item dot, or no, I could call that method here, display item. I So you see, I kept my main method very simple, just 3 lines, and these other methods will take care of it. All right, so if I run this, compile, let's run it, and then let's analyze the data. So I'm going to say hammer 25. So description is hammer units 25. Perfect. Now what that seems very intuitive. It's very simple. This is basically what you're going to do from now on if you want to use objects with methods. One of them is to pass it as an input, as we see here. The other is to return it as a return data type. That's very simple. What is not simple, and I want you to understand, is what is really happening in the memory in the background. All right, so that is the key challenge that we want to learn about here. So let's look at this. Our stack memory. Now here we can put item, right? Because we declared item. Now item at this point, we just said inventory item, correct? Now inventory item means it's just declared, it's not pointing to anything. So if you look at how this is visualized, what it's really doing is that it's pointing to null. All right, then I go and say get data. Now get data is going to go and just to remind you, let's have a look at the code here. Get data goes here, gets all of these information. So you have the description, you have the units, description and units is going to be in the stack memory, description is going to be a string in the heap memory, and so on. And then it's going to create that temp item, right? So here we have another, keeps rotating. There we go. All right, so here we have another item here, which is called temp item, which has an address pointing to an actual inventory item in the memory, which we called here with description being hammer and units, if I remember correctly, 25, something like that. All right, so units 25. Perfect. Then what happens? What happens later on is that we return that temp item. Now it's returned as an inventory item, and it's going to be returned to item. So what does that mean? What it means is that item here, and let's use a different color, item here is going to get that address here. Which makes item now not point to this anymore. Instead, it's going to be pointing to this inventory item. Then later on, of course, since you exited that, you return from that method, that temp item is going to be eventually destroyed later on, and it's going to vanish. So you see what happened here? You create temp item, it's pointing to actual object. Item at this point is pointing to null. Then we return as a data type here inventory item and assign it to item. Now what is really happening is that item is receiving the value, not the actual content. So it receives the address and it stores the address here, which points to that object in the memory. And that's how you get an inventory item or the object out of that method. All right, so that's the main concept here. Address is the one that gets copied. That object is going to be pointing, or that reference variable is going to be actually pointing to the same object in the memory. Now, one last note before we move. or before we actually conclude this lecture, is that if you look here in this code, now if you think about it, this temp item, as I said, it's going to get destroyed. It's really temporary. It's not important. We're not going to use temp item never again. It's local reference variable. It's going to be destroyed. We're not going to use it again, right? So the question is, do you really need to build it? Do you need to declare temp item? The answer is, it doesn't really harm to declare it, but at the same time, it's redundant. And what you could do is, instead of building something so you can return it, you could just simply return that new thing. So I could do something like this here. I could go and say, return a new object called of type inventory item that has disk and units as inputs. So what is gonna happen here is that it's going to create a new object called inventory item, or of type inventory item. It has disk and units, and then return that address, temporary address that was created to item here, right? So that's something just to keep in mind. You could do this instead of building that temp item that was really temporary and you didn't really need it for a long time.